Hello everyone, it's October 17th. I'm late today. It's past 5 p.m. so I have to use a time travel card. But that's fine, I already got it. So after I finish this, it should be noted that I time traveled. So this is for today. It's called path sum number 3. Alright, medium question. Let's take a look. Given root of a binary tree, an integer target sum return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downwards, traveling only from parent nodes to child nodes. So given this target is 8, I have this, and this, okay. Backtracking, right? So we have every single one, right? So like given a node 10, the path sum of the path from the one node to all of its children, right? So like for 10, if I want to get to 8, I need the sum of this path, whatever path it is, to equal to minus 2. But I don't have minus 2, therefore I don't have anything from here. And from 5, I need 3. So I need something down as 3. Okay, I need something down as 3. So I go down here. Is 3. I need something as 5, right? So I go down 5. No, what am I returning? I'm returning all the sums from me going down. So if I want to return to my parent, I have to return 3, that's me. And I'll return 6 and return 1. Right? That's the 3 values I return to 5. And from 5 I got, I have lots of values to return. Or I just keep going, so it's 10 when I go here. So I know the path to here is 15, right? And also I start from here and going down. So this path is 8, but then the path from here will be 18. All right, and I go here, this path is, and still, there's going to be a lot. Every single one will have a sum. How should I do this? Number of paths where the sum of the values along the path equals target sum. Okay, so if I ask a question, the number of paths that involving this will equal to 8. How many? Which is equivalent to say the number of paths starting from here will equal to 2, or number of paths equal to 2. Or the number of paths from here equals minus 1. The number of paths equals 3. No. Again. If I'm at 10, I want an 8, so I need a minus 2. So I ask my left child, how many paths you can give me that will equal to minus 2? Right, that's what I want. How many is minus 2? And then I ask this, how many is minus 2? So for here, what I need to know is how many is minus 2, and then I want to ask how many my children can give me 3. But then I also need to know how many my children can give me minus 7, right? So it's actually 2 requirements. From top down, I have more requirements. How many are we talking about? Number of nodes is 0 to 1,000. Keep track of the sum. Okay, what if I keep track of the sum? So I'm here. So this will be 15, right? And then I can compute the sum of each branch, like each path. Like I can say here I say that's going to be 21, right? I know this value, I know this, like this path. Like each path, I know the sum towards the end. Okay, how does that help us? If I know the path to here, how do I know the of these two? That's this minus this. But this minus this give us this value, not this value. Okay, so we know 10 to 3, right? Because I going down this path. Yeah, so this will be the sum of, what if I have multiple parents? No, that's just a path. This is a path. A path down, that would be 18, right? So a path down here is 18. And a path down here is 15. And to get these two, it's actually going to be this minus this, right? How do we know? Let me draw it out. So if I say this is 10, this is 15, 18, 21, this one will be 16, right? This one will be 17. This one will be 18. This one will be minus 7. No, this one will be 7. And this one will be 18, right? So if I given this, how does it help us? Each one is the sum until this. So if I want to know any intermediate path, is going to be the entire thing until that minus the previous one, right? So if I want to know these two, it's going to be 21 minus 15, which is 6, okay? If I want to know these two, well, that's just 15. If I want to know these two, it's going to be 18 minus 10, okay? So once we see this, right? Once we see this, we need to fit, like we need to find any path, right? Any path, the sum of any path can be computed as the difference between two values. The values of the end of the path minus the value of the beginning of the path. Well, actually, no, the value of the parent of the beginning of the path. So if I want to know this path, it's going to be value of this minus this, right? This minus this, this minus this, okay? So if we build this, and because we are saying going to be minus the parent, right? If we want to know these two, it's going to be this minus this, okay? So what we're going to do is go through the entire thing, right? We go through the path, and we're going to record, right? We're going to record all the parent value that occurred during the path, and as we come here, like let's say, it doesn't matter, right? So it's like a path, as you're coming down a path, At each one, I have a new value, and we can assume that if that value can be, if that node can be the end node, then sum of the parent along this path needs to make it to the target. So if I go 10, go 15, so 10, no, I cannot do it myself. So like the value for 10's parent is 0, right? So we always put zeros in there. So I have a 10, then we have a 5, so now this one is 15. And say, in order to get, we need 7, so we search for a set, right, of the previous. We don't have 7, so no good. We're going here, this one gives 18, but then we have the previous set is going to be 10 and 15, right, 10 and 15. Now it's 18, we need 10. Oh, 10 is in there, so oh, that's 1. And then coming down here, this will be 21, and then we have 18, 15, and 10 in there. But 21 requires 13, and we don't have 13, so this one's no good. We can come here, and since we only have 1,000, so at most the set is 1,000 in size, which is fine. Yeah, I think this might work. This might work. So let's try it. Let's be 17 today. 17 today. All right. Oh, I think about tomorrow. Tomorrow's gonna be a bad day. I need to go to DMV tomorrow. I already dread it right now. Just thinking about it makes me feel uncomfortable. That's like the whole afternoon is gone. Ay. Sad. Alright, so here is what I'm thinking about. So we're gonna traverse, right? So it's gonna be a DFS for sure. But we're gonna create a set. Oh, it is. It is a backtracking, but in terms of set. So all the like a parent sum, previous sums, I call previous sum, right? Previous sums equals a set. And then def DFS, right? And have a node. It's going to be a optional tree node, probably optional tree node. And right, this is a fine. And we need a parent. So we need a sum which is pre-sum, pre-s, pre. I have to call it pre. Alright, pre-sum set. How about that? And then this is going to be a pre-sum. That's going to be int. We're not going to return anything, but we're going to have a result. Self.res equals 0. And this one not going to return anything. Alright, so actually, if node is empty, right? If node is empty, we just return. So node has to be, so if node, right? If node, then we can say the current sum equals node.val plus pre-sum, right? And then we're gonna check. I check if target sum minus current sum is in pre-sum set, then self.res plus equal 1. Else, then it's not. And then pre-sum set dot add current sum, and we do DFS, node.left, current sum, and DFS, node.right, current sum. And after we've done that, pre-sum set dot remove current sum. And when the DFS root, pre-sum will be 0 because then we start, and we return self.res. All right, let's try this. We have 2 test cases. Let's see. Not right. Okay, something's not right. Let's try it again. The first one. Okay, well, I say if no, so if 10, right? And then current sum equals no.val, which is 10. And target is 8 minus 2 is not in pre-sum set. Pre-sum set needs to have a 0. So that needs to have a 0. So, but a 0 is not in it, right? It's a pre-sum set. Oh, hold on. Should we have a 0 in it? The target sum minus the current sum. And my output is 0. That's suspicious. Target sum is 8, minus current is 10, minus 2. Is not in, then we don't do it. Then pre-sum, add 10. 10 is the pre-sum. 10 is added to pre-sum set. And then we go left, and we go right. So now we go left, right? And then current sum is 10. 5. Current sum is 5 plus 10 is 15, right? And then target sum is 8 minus 15. So what we want is 15 minus something equals 8. So it's 15 minus 8. It's current sum minus target sum. Minus target sum. Alright, let's try this. Reversed it. Now you're right. Should we add a 0 at the beginning? I think we do, because if the starting point, let's say if the starting point is 8, right? And then we want to find 8. And that should be 1. And it will only be 1 because the target sum is initially. But now there's a problem. As we go through, what if we find something that the new value added is a duplicate, right? Let's say, yeah, it could be a duplicate. Think about it. It could be a duplicate because whatever the pre-sum we have in the food, like this is 0, right? We set 0 is, but what if I have this is minus 10, right? So 10 is 10. This becomes 0, right? And then as we go back here, we pop this out, and we remove 0, but 0 should still be there. Therefore, it should not be a set. I think a set is not correct. So I'm gonna use a counter. And counter is a better choice. So this is gonna be a counter 0, right? Because the initial is 0. And also, we're not going to call it the pre-sum set. This would be a pre-sum counter, right? And I want to change. First of all, it's current sum minus this. If, actually, it's going to be if pre-sum counter current sum, pre-sum counter current sum, no, not current sum minus target sum. If pre-sum counter this is larger than 0, then we have it. And we're going to say pre-sum counter this plus equal 1, right? And blah, blah, blah. Just simply we say pre-sum counter this minus equal 1. All right, we'll just, yeah. This way, if we have duplicates in the sum, it should still work. Yeah, and then I think this is good. Yep, let's try this. Oh, I've done this before. Oh my, I have a wrong answer. I done it in August 2020. That recycling problem, but oops, oopsie daisy, I got a wrong answer. 0, 1, 1. Hold on. What the heck? 0, 1, 1, and 1. Hold on. Let me write this. 0. 1 and 1. And is 1. Result is expected 4. Wait. Hold up. Can we do tree visualizer? Too many. Okay, hold on. We have 0, 1, 1. And 1. Oh, 1, 2, 3, 4. Dang. That's true. It is 4. Okay. Turn it off. Alright, so we need to change a little bit. Current sum minus, hold on, so we start with 0, right? And then 0 is 1. We start with 0, and we say 0 requires a 1, but 1 is not in it, so it's not. And then I'll put 0 in it, so 0 have actually 2 counts. Now we go to 1, right? I'll go to 1. So the current sum is 1. And pre-sum counter would require 0, and that's it. So pre-sum plus 1. Okay, that's good. How do we count the other? So this one is from 0 to 1. I counted. But 1 can also by itself. So what we should actually count is how many. It's not plus equal 1. It's plus equal to pre-sum counter, right? Because that means that that many previous values can reach this value. So we don't even need this. We should just plus equal to this. All right, let's try this one. If we do this, this one will pass. And we can use all the test cases. And these two shall pass as well. All right, try this one. There you go. There are 2 uncommon challenges. You have 1 ticket left. Yeah, you want to do ticket for makeup? Yes, I want to make up for this one. All right, so if we go back here, fresh, and this one shall show as completed. There you go. Show as completed. Okay, so pretty well. 44 milliseconds. Yeah, so it was correct. So we had a little bit back and forth, right? A little bit back and forth at the beginning, but we very quickly settled on using counter instead of a set to record the sum of previous nodes in the path. Yeah. So basically, the ideal is to the idea is that in order to examine whether a node can be the end of a path that satisfies the requirement, we need to see if if the sum of the path from root to the current node minus the sum of the path from root to sum of the previous node is equals target sum, right? In other words, we are looking at whether sum of the path to the current node minus target sum exists in any of the previous path sums. And we use a counter to keep track of the number of previous paths that have a specific sum. And this turns the problem into a two-sum problem. It is important to add the value from this counter, because there could be multiple previous path sums that satisfy the requirement, and all of them shall be counted. Yeah, so it's this is key. All right, runtime will be on because each node visit once, and then this is also on. We get a 44 seconds or a 95. It's not ranking. I'm pretty sure this is the solution. So just to see. This is the last solution I submitted last time. Actually, I also want to see what did I do initially. Oh, look at this. Interesting. 2020. I start from 1 o'clock, and then I did it again at 6 o'clock. Why? I don't understand. I did it 2 times. So this is 36. Sum of root to the current node, plus dot get, left, right, minus 1. Oh, that's exactly the same as what I had this time. Self.res, self.target equals this, self.dfs. And now I'm passing this. What is this target? Self.target equals sum. What? What is this? You don't need target. I mean, the self.target never really change. Alright? Self.target never really change. Yeah, I don't need that. Yeah, so it's the same. It's the same solution. This is the first time I try it. I use a counter and I use an index. I did all sums. I don't know about that. I don't want to understand this. I mean, I don't remember this solution, but we eventually did converge to the same. So that's a good sign. That's a good sign. That means we have improved. Although we did have a wrong answer, but we did improve on this one. Yeah, I think the intuition mainly is just it's an interval, right? Whenever it is an interval, and you want to try to find the sum of intervals, the prefix sum, or some variety of it. This is actually a variety of prefix sum, right? Just instead of on a array, we're doing it in the tree, but each branch, or the so-called each path, can be seen as an array, right? It's an array, and then we can do the cumulative sum, the prefix sum, which will help us find out all the sums of all possible intervals. And they only ask for the total number, which means they don't really care about the exact path. So a counter is the way to go. Yep, this is the way. All right, pretty good, pretty good. Actually, we already see what we have tomorrow, right? That's what we have tomorrow. Cousins in binary tree. Ideally, tomorrow we do this. We shall do another one because you know what? Yeah, we'll do it tomorrow. That's it for today. See you guys tomorrow. Adios.